In this video, we will review the nomenclature of ethers. So remember, ethers are molecules where there is an oxygen atom bonded to two carbon chains. So that's the ether functional group. Of course, if we have different carbon chains, we have different names. And for ethers, they're actually more referred to as, or through their common names than through the IUPAC name. So we'll talk about both, but really we want to remember the common names of ethers. So we'll look at molecules, we'll name them with its common name and following the IUPAC rules. So you can kind of see the difference. They are similar, but the common names are quite intuitive. So a common ether that you have probably seen in the lab space is diethyl ether. This is a solvent, it's liquid at room temperature, and it's very commonly used as an aprotic solvent because ethers are all aprotic. They do not have an acidic proton. So diethyl ether, that's actually the common name. So let's draw that out. We have two ethyl groups, and those are the two R groups for the ether. So here we have an ethyl group bonded to the oxygen. On the other side of the oxygen, we also have an ethyl group. So the common name for this molecule is diethyl ether. And that's what's on the bottle in the lab space. The IUPAC name is probably also on the bottle, but in the lab when we're talking about this solvent, we call it diethyl ether. The IUPAC name, we follow IUPAC rules where we look for the longest carbon chain and then any substituents on that chain. So in this case, the longest carbon chain is an ethyl chain. You could pick, of course, either side to reference that as your longest carbon chain. So we have an ethane molecule. A substituent on the ethane is the rest of this molecule, and this is an ethoxide or an ethoxy substituent. So in this molecule, ethane is the main carbon chain. We have an ethoxy group on carbon 1. So this is 1 ethoxy ethane. And that is the IUPAC name for the same molecule. Let's do one more. Oops. Or we have two different groups bonded to the oxygen. All right, so looking at the molecule that I drew first, for the common name, we have the oxygen in the center, so it's an ether molecule. On one side, we have a methyl, just a CH3 group, and on the other side, we have 3 carbons, so that's a propyl group. But in this case, the bond is at the center carbon, so this is the isopropyl group. It's one of the specific carbon chains in a specific bonding pattern that we named in Organic Chemistry 1. So we have a methyl group, isopropyl group. We essentially name both of those and then add the word ether. To arrange methyl and isopropyl, we put the name that comes first alphabetically in the front. So I in isopropyl comes before M in methyl. So this is isopropyl methyl ether. For the IUPAC name, the first step is finding the longest carbon chain. And in this case, it is the isopropyl group. We have 3 carbons in a row, so that is the longest carbon chain. And then we have the methyl group as the substituent. Oh, sorry, not the methyl. We have to include the oxygen, so we have methoxy as the substituent. The longest carbon chain gives us a propane suffix for this name. We, in the name, now number that the methoxy group is on the second carbon in propane. So the name for this molecule, the IUPAC name, is 2-methoxy propane. We'll certainly do some more examples in class, but focus on the common name, identifying the 2 substituents on the oxygen and arranging them in alphabetical order. But it's also useful to know the IUPAC name. You already know these naming rules, so you would be able to name these molecules using IUPAC rules either way.